Assalamu alaikum. My name is Anand, and today I am going to present a comparative study between random forest and XGBoost. In this presentation, I will explain how this algorithm works, their differences, strength, weakness, architecture, and why we should use one over the other. Here is the overview of my presentation. First, I will introduce ensemble learning and explain why it is important in machine learning. Then I will discuss the decision trees because both random forest and XGBoost are based on decision trees. After that, I will explain bagging and boosting techniques, followed by detailed discussions of random forest and XGBoost. Then I will compare them head to head, explaining their architecture, analyzing performance on real-world tasks, and discuss why to use each algorithm. And finally, show some practical application. Before understanding random forest and examples, we first need to understand ensemble learning. A single decision tree is simple and easy to understand, but it has some problem. It can easily overfit the training data, and even small changes in data can completely change the prediction rate. Ensemble learning solves this problem by combining multiple models together. This is called the wisdom of the crowd concept. Instead of relying on one weak model, we combine many models to create one strong and stable model. The major two principal techniques are bagging and boosting. A decision tree is a flowchart-like machine learning model that makes prediction by splitting data based on conditions. Internal nodes represent feature taste, branches represent outcomes, and leaf nodes represent final prediction. For example, in a non-approved system, the model may check age, income, student status before deciding whether to approve or reject a loan. Decision trees have several advantages. It is easy to understand, easy to visualize, can handle non-linear relationships, require little processing. However, they also have limitations, overfitting, instability, bias towards certain features. Now let's compare bagging and boosting. Bagging stands for bootstrap execute. In bagging, multiple models are trained independently and in parallel. This model uses a random subset of data. Final prediction is made using majority voting. The main goal of bagging is to reduce barriers. Random forest uses bagging. On the other hand, boosting trains model sequentially. This new model tries to correct the mistake made by previous model. The the final prediction is calculated using weighted combinations. The main goal of boosting is to reduce bias and improve accuracy. XGBoost is a boosting algorithm. An ensemble learning algorithm based on bagging. It combines many decision trees together. Each tree is trained on a random subset of data and random subset of features. Finally, all trees put together to produce a final prediction. Thus, main strength of random forest are reduced overfitting, good handling of missing values, feature importance analysis, parallel training, which makes it faster. However, it also has some weakness. Less interpretable than a single tree, requires more memory, prediction can be slower with many trees. Common application includes fraud detection, medical diagnosis, stock prediction, and feature selection. XGBoost stands for Extreme Gradient Boosting. It is an optimized boosting algorithm designed for high performance and accuracy. Executes works sequentially. First, it makes an initial prediction, then it calculates error, also called residuals. A new tree is trained to correct those errors. This process repeats until the prediction error becomes very small. The major strengths of XGBoost are very high accuracy, built-in regularization, fast optimized implementation, excellent performance on structured data. Weakness includes more hyperparameters to tune, longer training time, harder to interpret. XGBoost is widely used in credit scoring, ad ranking, recommendation systems, and Kaggle computations. Random forest and XGBoost. Random forest trains faster because trees are built in parallel. XGBoost trains sequentially, so the training is slower. In terms of accuracy, XGBoost usually performs better. However, random forest is simpler and easy to view. Random forest has lower overfitting rates, while XGBoost can overfit if hyperparameters are not tuned properly. For scalability and handling large datasets, both are very strong, but XGBoost is often preferred for competitive machine learning tasks. This slide shows the structural difference between two algorithms. In random forest, trees are trained independently. All trees work in parallel, while prediction is based on voting and averaging. In XGBoost, trees are trained sequentially. Each tree corrects the errors of the previous tree, while prediction is a weighted sum of all trees. So the key difference is random forest focuses on parallel independence and XGBoost focuses on sequential error correction. This graph compares the performance of random forest and XGBoost on a different real-world dataset. We can observe that exhibits consistently achieve a slightly higher accuracy, usually around 5 to 6% better than random forest. The performance difference becomes especially noticeable in structured and tabular datasets such as credit risk prediction, house price prediction, and customer churn analysis. This is why XGBoost is extremely popular in machine learning computation and industry applications. Now the question is, when should we use random forest and when should we use XGBoost? We should use random forest when we need a strong baseline quickly. We want less hyperparameter tuning. Interpretability is important and computational resources are limited. We should use XGBoost when maximum prediction accuracy is needed. We can spare time tuning hyperparameters or we are working with structured dataset. So the choice depends on project requirements. Both algorithms are widely used in real-world systems. Random forest is commonly used in fraud detection, medical diagnosis, feature importance analysis, and e-commerce recommendation system. Most is commonly used in credit scoring, search engine ranking, ad click prediction, and Kaggle computation. These applications demonstrate how powerful ensemble learning methods are in solving practical business and research problems. Thank you for listening to my presentation. Assalamu alaikum.